Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at how to multiply binomials. To introduce you to this, let's review how to multiply two-digit numbers with an area model. So here I have the question 47 times 98. So what I'm going to do is I'm going to place 47 and 98 on this rectangle. But I'm going to split up 47 into 40 and 7. So I have 40 as a longer length and 7. So this will represent the width. I'm going to do the same thing with 98. I'm going to split it up into 90 and 8. Now the reason I've done this is because it's easier to multiply a single number with maybe a 0 or no 0 at all than it is to multiply two-digit numbers. So in this first big rectangle here, we have 40 times 90. And we know that 4 times 9 is 36. And then both of these numbers each have one single 0, so we have 3,600. Next, we have 40 times 8 with this skinny rectangle at the end. And 40 times 8 is 4 times 8, which is 32. And this has one 0, so we add a 0 at the back. And then we have 7 times 90 for this bottom skinny one. 7 times 9 is 63, and then we have a 0. And then finally we have 7 times 8 for this tiny rectangle on the bottom here, and that's 56. So now we have the area of each of these rectangles, and now we have to add them all up. So we have 3,600 plus 320 plus 630 plus 56. And we just have to add all four of these numbers together. So we get 6, 5 is 10, carry the 1, 6, so 12, 13, 14, 15, and then 16. Carry that one, and then 3 plus 1 is 4. So the area of this rectangle is 4,606 units squared, or we also know that 47 times 98 is 4,606 as well. All right, so now let's extend this idea to multiplying binomials with algebra tiles. So remember that a binomial is a polynomial with two terms, and then the product of the two binomials can be illustrated with the algebra tiles, like I'm going to show you here. So here we have x plus 2 and x plus 3. So we can say that x plus 2 is the width, so we can label this as x plus 2, and then x plus 3 here can be the length. X, and then plus 3. So the area is x plus 2 times x plus 3. Now I'm going to draw my rectangle in here to show the area after multiplying these two binomials together. We're going to extend the lines where the tiles are have a space in between them, so we can go through here, across, and also vertically. All right, so we can see that this big square here is a positive x squared. Now you don't have to put the positive sign, so we're going to erase that because we don't need it. And then we have x times 3. So we have 3 x's over here. So x, x, and x. And then we have 2 times our x, and these are x tiles as well, but they're just lying horizontally. So this is also x and x. And then finally, we have 2 times 3, which gives us these single units down here on the bottom. And there are 6 of them. So you can put a plus sign in them if you like, although all of these would be positive as well. So you can shade this to show that they're all positive, or you can just leave them blank, but put a plus sign so that we know that they are all positive. All right, so we can see that the area can be represented by adding up all of these different tiles together. So we have the x times x, which gave us the x squared tile. So we have x squared plus, and then over here we had our 3x. And then on the bottom part, we have our 2x. And then finally we have our 6 single ones, so plus 6. So you can see, just like a rectangle from above, we divided up our area into 4 pieces, into 4 rectangles. So a big one here, 2 skinny rectangles, and then a small rectangle on the bottom. Just like here, we have a big x squared, our x's on the top and the bottom here, and then 6 single units here. When we simplify, we're going to get x squared plus 5x and then plus 6. And that's how we multiply x plus 2 times x plus 3, and this would be the result, x squared plus 5x plus 6, which is a trinomial. Let's take a look at this a little bit more closely. So what we did was we took the first term in the first binomial, which is x. So in the picture, it is x here. And then we multiplied it by x plus 3 to give us this top part of our rectangle. So it's x times x plus 3, the second binomial. And then what we did was we took 2, which is our second term in the first binomial, and then we multiplied by x plus 3 again to give us this bottom part of the rectangle. So notice it was 2 times the x plus 3 again. So we take the first term in the first binomial, multiply it by the second binomial, and then we take the second term in the first binomial, and then again multiply it by the second binomial. All right, so let's take a look at how to do this algebraically without the diagram. All right, so let's summarize that first. When we multiply the 2 binomials, we are using actually the distributive property. And we're using it to expand the product. Now it's a little bit different from before where we only had one set of brackets and a monomial in the front. Now we actually have 2 binomials. So we multiply each term in the first binomial by every term in the second binomial. All right, so this is what it would look like if we expanded it. So in this first example here, we have x plus 3 times x plus 5. So we're going to take x from the first binomial, and we're going to multiply it by x plus 5. So this is what that would look like. And then we're going to go plus 3 and do the same thing, multiplying it by the second binomial, like so. So now we're going to expand this, like we've done before with our distributive property. So x times x is x squared, x times 5 is 5x, and then positive 3 times x is plus 3x, positive 3 times positive 5 is plus 15. Simplifying the middle 2 terms because they're alike, we have x squared, 5x plus 3x is 8x, and then plus 15. All right, let's do another one where we have a negative sign so you can see the difference. So again, we're going to take the first term in the first binomial, it's x, times it by the second binomial, so x minus 5. And then we're going to do the same thing with the 3. So plus 3, and then multiply it by the second binomial. So here we have x times x, x squared, minus 5x, plus 3 times x, and then 3 times negative 5, which is negative 15. Again, we can join the 2 middle terms because they are alike. So we get x squared, negative 5 plus 3 is negative 2x, and then minus 15. All right, let's do one more in this row here, where the first binomial has a minus now. So we have x again, first term in the first binomial, multiplied by x plus 5. And then we have the second term in the first binomial, which is a negative 3, and then x plus 5. All right, so multiplying this out, I get x squared plus 5x. In the second part, I get negative 3 times x, and then negative 3 times 5. So that's negative 15. And again, I can join my two middle terms. So that's going to be x squared plus 2x minus 15. Now, we've done a plus plus, a plus minus, and a minus plus. So let's finish off with a minus minus. So we get x as our first term multiplied by x minus 5, and then minus 3, and then again times x minus 5. So when I expand, I get x times x squared, minus 5x, and then negative 3 times x, and then negative 3 times negative 5, which is plus 15. And that equals x squared minus 8x, and then plus 15. All right, let's do a few more examples where we now also have coefficients with the variable. So we have 4n, our first term, times n plus 5. And then we have plus 7, also times n plus 5, our second binomial. So expanding, 4n times n is 4n squared. 4n times 5 is 20n. And then we have plus 7n. And then 7 times 5 is plus 35. And again, join your two middle terms. We get 4n squared plus 27n, and then plus 35. All right, let's do another one of these for practice. So you can try this on your own first if you want, and pause the video, or you can also watch. So 2y from the first term times 4y minus 5, and then plus 3, and then 4y minus 5 again. So this gives us 8y squared minus 10y, and then 3 times 4 is 12y, and then minus 15. And that gives us 8y squared plus 2y, and then minus 15. And here are a few other different types of examples. I recommend that you try them on your own first by pausing the video and then replaying it to see if you got them correct. I'm going to actually write them out quite quickly here, and then you can compare as well. So distributing again, this time we have m squared times m, so it's m cubed, plus 4m squared, and then negative 2 times m, and then negative 2 times 4. So notice for this one, there are no like terms to combine after we distributed, so that's it. Okay, and then in h, we have x times 4x minus y, and then negative 3y, also times 4x minus y. So we get 4x squared. This is a little bit different. We have x, so negative x times y, and then we have minus 12, and then let's put this in order, also xy, and then negative 3y times negative y, which is positive 3y squared. And then we have 4x squared, negative 13xy. We can combine the two middle terms together, and then plus 3y squared. All right, and the last one here, we have negative m times 2n plus 5m, and then our second term is negative 3n, also times 2n plus 5. So negative m times 2n is negative 2mn, and then we have negative 5m squared, and then negative 6n squared, and then negative 3n times 5m is negative 15mn. And then putting in order, we have negative 5m squared minus 17mn, and then minus 6n squared. And that's how you multiply two binomials together.